Good afternoon, sir.
Good afternoon. We'll wait for about a minute or so and then we will get started. Nidhi, please switch on your video. Arshita, Nidhi Bhatia, Mayank and Arun, switch on your videos. Nidhi, Mayank, Arun. निधि एंड अरुण प्लीज स्विच ऑन योर वीडियोस। तो आज हम कार्बन चैप्टर का रिवीजन करेंगे, ठीक है। तो कार्बन चैप्टर एज यू नो कार्बन एज एंड इट्स कंपाउंड में बहुत कुछ तो रिमूव कर दिया गया है इस साल, राइट। द मोस्ट ऑफ द कंपाउंड्स पार्ट इज एक्चुअली रिमूव, मोस्ट ऑफ इट, ठीक है। तो एथेनॉल, एथेनोइक एसिड, उन सब के रिएक्शंस तो हटा दिए गए हैं। Okay, so that leaves us with very elementary part of this chapter, ठीक है। तो वो हम आज रिवीजन करेंगे। और you also tell me what would you like to revise tomorrow, right? I don't think we need 2 days maybe to revise this. Okay, it's a reduced syllabus. वैसे जब when you did this chapter, have you done the entire chapter or only the part which is relevant this year?
Only to avoid the confusion that what is coming and what is not. We were
Hmm.
so much confused for ensuring that we have supposed that chapter to be revised.
Okay, okay. So see, yeah, that confusion is there because even in the document that is provided by NCRT, okay, if you read that document, then technically all the compounds are out other than the alkanes, right? Alkanes, and we can say alkanes, alkenes, and alkynes because they have even removed the difference between saturated and unsaturated. Okay, explicitly they have removed that. The nomenclature also they have removed for the functional group. Okay, and ethanol and ethanoic acid is also removed. Okay, so but when you did in the class, have you done the entire chapter or only the
No,
part which?
sir. Ma'am also told us somewhat basics about this chapter, which are to be studied importantly.
Hmm,
If although they are being removed from the syllabus, but still they told
okay.
so that we understand the other topics
Huh.
easily.
Yes. So I think that's the approach we will take. But see, अभी final exams को तो काफी समय है, right? So it's a good idea to do the entire chapter. Anyway, you know, chemistry is a science subject which will stay with you if you stay with the science stream. Okay, whether you go for medical, non-medical, you know, chemistry is common to both. Okay, and hence I would suggest that, you know, carbon and its compound is the introductory chapter for organic chemistry, which is one of the largest part of chemistry when you study in class 12. So these basics are going to help you. So it's a good idea to go through the entire chapter is my suggestion, right? But what ends up happening is if we look at the board papers for the last 3 4 years when this chapter was
Done.
Hello. Yes.
Good afternoon, sir.
Good afternoon. ओके सो अगर हम इसको क्वेश्चंस देखेंगे तो मोस्ट ऑफ द क्वेश्चंस टेंड टू कम फ्रॉम either nomenclature, 1 mark question type of questions are nomenclature kind of questions, and most of the questions come from esterification, saponification, and some reactions of ethanoic acid or ethanol, like ethanol with the sodium, etc. You know, these are the common questions to be asked in the board, but those are explicitly removed. So if you really look at it, the board questions are no more useful for us for revision for the current syllabus. Okay. So my sense is that this chapter will carry lower weightage this year, okay, compared to in the past when in chemistry this was definitely one of, you know, periodic table, and this were the high weighted chapters, right? Let um, continue and at least go through the basics of this today. Okay, so what is the propensity of a C atom to lose 4 electrons and become C positive ion, or gain 4 electrons and become C negative ion, to share 4 electrons and form a molecule accordingly? All of the above. Which is the propensity of C?
Here 4 electrons.
To share electrons, right? So just C here, it will share electrons, it will not do these. Okay. Why would C not easily lose 4 electrons? C means carbon here, of course. Why would carbon not easily lose 4 electrons? What would be the answer? बोलिए.
Because there is a lot of energy required to lose 4 electrons.
Yes. Okay. So the answer is energy required. Perfect answer. Okay. So the energy considerations is an issue here. It requires a lot of energy. So what actually happens is pulling out 1 electron is easy. But once we pull out 1 electron, what happens is that the nucleus compared to the electrons outside is relatively stronger now. Okay. And we pull out the second one, it takes more energy to pull out the second one. Pulling out the third one requires even more energy, and so on. So taking out 4 electrons take a lot more energy. Now the bigger issue is that carbon is also a very, very small atom. Okay. Why? Because carbon is just 2 shells, right? So the outermost shell electrons are very tightly bound to the nucleus. So if it was the group 14 element itself, but way down, right, in let's say period 4, period 5, then the because of its distance, the outermost shell being quite far away from a nucleus, right, it was still lesser energy required to pull that off. So the short and sweet answer to this is what actually Disha just said, that it requires a lot of energy to do so, and hence it doesn't do it. How many had just a second. Okay, so before we move to this question, why would it not gain? Let me ask the question, why can't it gain 4 electrons? Then how will you answer the question?
Its first
Good
reason
afternoon,
is
sir.
that the
Good
energy
afternoon.
considerations,
Good afternoon.
and the second reason is that when 4 more electrons will be gained, then it will become so much difficult for 4 remaining same protons to accommodate the 8 electrons in its shell.
Yes. So the answer is what you said is correct, right? For the, how many protons are there inside carbon's nucleus?
6.
6. So for 6 protons to hold 10 electrons will be a very difficult task. Okay, and hence that ion will be very unstable. Okay, so your answer is perfect. How many hydrogen atoms can combine with an atom of carbon? Mention the molecule thus formed.
4. Methane is formed, CH4.
Very good, right? So everybody is following this, right? So there is a carbon and there can be 4 hydrogen atoms, and all the electrons, valence electrons of carbon gets utilized in that. And there is no other way to do this, right? Because hydrogen can't form a double bond or anything else, right? So there is no other option. It can just be C4, right? So C2, C3, H2, CH3, those are also not possible. So there is an unambiguous clear answer, CH4, which is methane. C is the only element that can form covalent bonds with carbon and other elements. Is that true or false?
It is false because all the elements having 4 as valence electron can make covalent bonds.
Yes. So it is false. Okay. And perfect answer. Anything which has 4 or more valence electrons can form covalent bonds. What is meant by allotropy? What causes allotropy? Name a few elements that exhibit allotropy. Kana,
They are the compounds of the same element which exist in various physical forms. For example, it can be carbon, whose allotropes are graphite, diamond, and Buckminster fullerene, etc.
yeah, okay. So it is different forms, right? Exhibited within the same physical state by an element. That is called allotropy. Okay. What causes allotropy? Different
Due to its
arrangement
structural
of
differences.
atoms. Different arrangement of atoms. Okay. And which are the few elements which exhibit allotropy? Of course, carbon is one. And you gave 3 examples already. Which other elements can we mention?
Silicon can also make.
No, silicon is an example. I mean, silicon would be a better example for what? For catenation, right? We are talking of allotropy. So, which are good examples for allotropy? See, silicon can form different chain lengths, but still it will be called silicon, right? Oxygen, ऑक्सीजन ऑक्सीजन के एलोट्रोप्स के नाम बताइए.
O2 and O3.
Yes, O2 and O3. O2 को simply oxygen gas ही बोलते हैं या simply oxygen, and O3 is called ozone. Okay, another one you can remember is phosphorus. Okay, phosphorus has various allotropes. The noteworthy ones are white phosphorus and red phosphorus. Okay, white phosphorus is highly reactive and red phosphorus is very reactive, not like highly reactive. Okay, phosphorus is always very reactive, but white is like ultra reactive. Okay, water can exist as ice, water, and water vapor. Would you call these its allotropic forms? Give your reasons. Himanshu Sharma, Nishant Kasana, video on करिए रुद्र. What's your views? Is ice, water, and water vapor allotropic forms of water?
Yes, sir, it can be.
Okay. So the answer is no. Okay. The answer is no. Now tell me, why should it be no?
Sir,
Answer is
because due to
clearly no.
structural arrangement only, that is the difference between their molecules, they are present as different physical forms of the same compound water.
Huh. So see, the first thing, water is a compound,
Okay.
right? Water is a compound, so allotropy का question ही नहीं उठता है, right? Allotropy is a property of an element. ओके कंपाउंड के लिए वो डिफाइंड ही नहीं है वो प्रॉपर्टी फर्स्ट ऑफ ऑल. तो आंसर वहां पे कंप्लीट हो जाता है. लेकिन फिर भी जस्ट टू एक्सप्लेन, ice, water and water vapor are different physical states. Okay, for something to be called an allotrope, okay, it should be within the same physical state. जैसे diamond, graphite, buckminster, all are solids. Okay, so like ozone and oxygen both are gases. White phosphorus and red phosphorus both are solids. So same physical state में different forms जब होते हैं तभी allotropy कहा जाता है. And it is only defined for elements. Okay. Carbon having the molecular formula C60 is known as?
Buckminster fullerene.
Yeah, Buckminster fullerene. Okay, so this is a relatively newer allotrope of carbon which is known. Okay, there are many fullerenes. Okay, there are many types of fullerenes. I think starting from about C20 to all the way to C200 or something, right? So there are many types of fullerenes, but the one that we have to know is C60, okay, which is known as Buckminster fullerene, or the buckyball also it is known as. Describe the structure of a molecule of Buckminster fullerene.
It is like hexagonal and pentagonal rings joined together and looking like a football.
Yes. Okay, it is similar to a soccer football. Okay, so it's similar to a soccer football. It's made up of rings which are pentagonal and hexagonal.
12 pentagons and 20 hexagons.
Very good. Okay, it has 12 pentagons and 20 hexagons. Okay, and obviously 60 carbon atoms. Okay, can somebody, although that may not come in the exam, but why is it called Buckminster fullerene? Why this name Buckminster is coming here? Somebody knows that?
The structure of it was explained by Buckminster.
Okay. So that's not true, right? So this is one of the, and why I am talking about this is because this is possibly just interesting. Okay, कि usually क्या होता है, हम किसी चीज को उस साइंटिस्ट के नाम पे नेम करते हैं जिन्होंने उसके डिस्कवरी में या उसके एक्सप्लेनेशन में कुछ कंट्रीब्यूशन दिया हो, राइट? But actually Buckminster Fuller had nothing to do with this, right? He was an architect. Okay, he had built a architectural design which resembles the shape of Buckminster fullerene molecule. Okay, so just in his honor, and he was possibly is known as the father of the modern architecture. So he was definitely a very, very big architect. Okay, so just to honor him, as there was a resemblance to his architecture, this thing was named as Buckminster Fuller. And he wasn't the scientist who did anything about it. Okay, so that's a very strange but true kind of a thing. Differentiate between diamond and graphite based on their physical properties and relate its organization of, I'm sorry, carbon atoms in them. Okay, so जो carbon उसके क्या different properties हैं and how do we explain them based on the organization of carbon atoms in these molecules. So we can take a few properties and try to explain them based on the structure. So which properties do we take up? Which are the big differences?
Diamond is a
Graphite
three-dimensional structure. Graphite is a two-dimensional.
and is not.
So conductance ले लेते हैं, right? Conductance is different. Okay, so diamond and graphite. So diamond is a poor conductor and graphite is a good conductor. Okay, now let's explain that based on the structure. Diamond has a which structure?
Three-dimensional.
Three-dimensional tetrahedron. Okay, structure. So 4 carbon atoms are bonded to each carbon atom. Implies no free electrons. Okay, but in case of graphite, it is 3 carbon atoms bonded to each carbon atom, leaving 1 free electron, giving conductivity. What other property can we use? We can use rigidity, or let me say hardness. Okay, diamond is extremely hard, actually the hardest natural substance. Okay, extremely hard. And graphite is soft to touch. Okay, so I'm just saying soft to touch rather than saying soft, right? It's not like graphite is ultra soft and you can squeeze it like a sponge. Okay, but it is soft to touch. You touch it, you feel it's soft. So, why is diamond hard? It's a 3D structure. The entire crystal is essentially a single molecule that is connected by very strong covalent bonds. Okay, so this gives diamond extreme hardness. Okay, it's a single molecule, all the bonds are covalent. But in graphite, what happens? It has a planar structure rather than 3D structure. It is planar, as well as different planes are connected by which bonds?
Van der Waals forces.
Weak van der Waals forces, right?
Good afternoon, sir.
Good afternoon, sir.
सर मैं थोड़ा इन बच्चों को एक बार डांट दूं?
हाँ हाँ बिल्कुल बिल्कुल।
बेटा, डांट खानी है आपको, समझ गए होंगे कुछ लोग तो आप में से। अरुण, आपका बेटा शुरू से कैमरा ऑफ है, प्लीज ऑन योर कैमरा। हिमांशु शर्मा, हिमांशु, कैन यू हियर मी? रुद्र शर्मा,
रुद्र का तो ऑडियो ही कनेक्टेड नहीं है, बट I don't know, he has a technical problem or what, but he is definitely not listening to us. So
sir, please remove them.
I'll
We'll keep it. Just Rudra Sharma and Himanshu Sharma and Arun Kaushik. These three students from the beginning, I am just observing your class. They are not ready to on their camera.
Himanshu, Arun, आप लोगों को we are making a final call,
Himanshu,
right? Please switch on your
yes,
cameras.
yes. On your camera.
निशांत, आपका कैसे ऑफ हो गया बीच में अचानक? Yours was on.
Nishant, you should also.
निशांत, keep it on बेटा.
सर हमारा ऑन है।
अच्छा, ठीक है, ओके। Tinku,
please,
keep
you can
it on.
continue.
Tinku, keep your camera on. Okay. Coal is an allotrope of carbon. True, false? Give reasons. Is it an allotrope of carbon, coal? Is coal an allotrope of carbon?
I think it's not,
Okay.
because coal is not just carbon. It's a mixture of so many compounds along with carbon.
Very good. Very good. Okay. So coal is not. No, it is not. Okay. Why? See, I just explained what an allotrope has to be an element. And coal is not an element, it's a mixture. Mixture of elemental form of carbon as well as other compounds. Okay, there are many compounds. It's just a mixture, so composition changes with quality of coal, and it does have elemental form of carbon, but it is not the pure form. Okay, and hence allotropy does not apply to this term. Sodium is a much more reactive element than carbon, so it forms a large number of compounds compared to that of carbon. Okay, is that true or false?
Obviously not.
Obviously not true, right? We know that carbon forms the largest number of compounds. Okay, the compounds formed by carbon exceed the compounds formed by non-carbon elements all put together by a huge margin. Okay, the other compounds are only in the thousands and this is in millions. Okay, so carbon, obviously this is not a true statement. Okay, it also tells us that reactivity is not the key criteria, okay, for forming more number of compounds. It's a criteria of easily forming the compound, right? Because sodium is so reactive, you will not find elemental sodium in nature anywhere because it is so reactive. So it reacts easily. Reactivity only tells how easily it reacts. It does not tell with how many things and in how many ways will it react. Okay, carbon, you can find elemental carbon in nature, It is definitely less reactive, but it can form, combine in various ways, and hence the number of compounds is high. State the properties of carbon that are responsible for its large number of compounds. For its large number of compounds.
Tetravalency.
Yes. So there are two reasons we have to mention in this question. This is a standard question. Okay. The first is tetravalency. Okay. Tetravalency. And the second is catenation. Okay. Tetravalency से क्यों ज़्यादा compounds बनते हैं? Why does this contribute? See, tetravalency means that it can combine with a certain thing in multiple ways, right? अगर tetravalency ना हो, कम valency हो, right? Tetra is technically the highest possible valency in a stable state, right? क्योंकि अगर उससे ज़्यादा valence electron होते हैं तो फिर valency becomes 8 minus the valence electrons, right? Rare conditions where we have valencies like 6 and all. So normally tetravalency is very high valency, right? So it means that it can combine with other elements in different ways. Okay, in different organizations. Okay, so that's why tetravalency leads to more number of compounds. And catenation is the bigger reason, of course. Catenation is the key reason. Catenation क्या होता है? Its ability to form long chains with itself. Okay, carbon atoms link करके long chains बना सकते हैं with single, double or triple bonds. What is the meaning of saturated carbon compounds?
The carbon compounds with all the single bonds are known as saturated carbon compounds.
Yes. So carbon compounds which have all carbon-carbon single bonds. Okay. You missed out this keyword. Okay. So all the carbon-carbon bonds should be single bond. ओके मान के चलिए कार्बन का कंपाउंड है उसमें ये भी आता है तो उससे वो सैचुरेटेड अनसैचुरेटेड पे फर्क नहीं पड़ा ना कुछ राइट सो विल यू कॉल दिस सैचुरेटेड कंपाउंड और एन अनसैचुरेटेड कंपाउंड सैचुरेटेड तो आपको कार्बन कार्बन ऑल द कार्बन कार्बन बॉन्ड्स आर सिंगल ठीक है ना और किसी के साथ डबल बॉन्ड हो वी डोंट केयर ओके सो दैट इज कॉल्ड द सैचुरेटेड कार्बन कंपाउंड ओके और जिनमें कोई भी कार्बन कार्बन बॉन्ड डबल या ट्रिपल होता है उनको अनसैचुरेटेड कहते हैं between structured and unstructured carbon, so between saturated and unsaturated carbon compounds, which are more reactive and why? Anchal, Anmol, and Tinku, please switch on your videos. Anmol and Tinku, switch on your videos. बेटा इसमें टाइम वेस्ट होता है हमारे पास वैसे ही एग्जाम आने वाले हैं वी डोंट हैव टाइम प्लीज कीप योर वीडियोस ऑन बिटवीन सैचुरेटेड अनसैचुरेटेड कौन ज्यादा रिएक्टिव होते हैं और क्यों
Sir, if they are not following your instruction, please remove them from the class. This will be the easy for us.
Mhm. Tinku, you are the only one who doesn't have your video on. And your video was on, तो अभी क्यों ऑफ हुआ है? Tinku Sharma, whether you will lose
Maybe,
your attendance and I will have to remove you. Quickly switch it on. I don't think he is there
Sir?
at all. Okay. बताइए कौन सा ज्यादा रिएक्टिव होते हैं सैचुरेटेड वर्सेस अनसैचुरेटेड में? ओके, सो अनसैचुरेटेड आर मोर रिएक्टिव. And why is that? It is because from a carbon-carbon double bond, breaking the second bond is less energy intensive than breaking the carbon-carbon single bond. So the energy needed to break the additional bonds, okay, is lesser than energy needed to break the primary bond, the sigma bond, okay. So but we will not use those terms. We will just say that to break the second bond, okay, in a double bond or the third bond in the triple bond is much lesser than breaking the single carbon-carbon bond, right? But इसी के जैसा एक क्वेश्चन और पॉसिबल हो सकता है. Okay, if I ask you which bond is stronger in this, which is the strongest bond in this? Then what will you answer? Someone can answer this? डबल बॉन्ड, ट्रिपल बॉन्ड, सिंगल बॉन्ड, ये कार्बन के मैंने बॉन्ड्स दिखाए, इसमें से कौन सा बॉन्ड सबसे स्ट्रांग है?
CC bond.
C.
Which CC? ट्रिपल, डबल या सिंगल?
C
Single
option.
bond.
Actually, this is the strongest, right? तो ये दोनों थोड़ा ऑपोजिट लगते हैं सुनने में, राइट? दोनों बातें. यहाँ पे हम बोल रहे हैं अनसैचुरेटेड में बॉन्ड ब्रेक करना इजी है, यहाँ पे बोलेंगे कि ये सबसे स्ट्रॉन्ग बॉन्ड है. तो ध्यान दीजिए, देयर इज अ डिफरेंस दोनों बातों में. अनसैचुरेटेड पूरा बॉन्ड, ये जो बॉन्ड है ये बहुत स्ट्रॉन्ग है. क्यों स्ट्रॉन्ग है? क्योंकि हमें कुछ एनर्जी चाहिए ये पहला बॉन्ड ब्रेक करने के लिए, राइट? फिर कुछ एनर्जी चाहिए हमें ये बॉन्ड ब्रेक करने के लिए, और फिर कुछ एनर्जी चाहिए हमें ये बॉन्ड ब्रेक करने के लिए. ऐसे मान के चलते, although these numbers are not correct, but just assume that we need 1 joule of energy to break this bond. Assume we need 2 joules of energy to break this bond. And we need 3 joules of energy to break this bond. Then what is the total energy needed to break the triple bond? 1 plus 2 plus 3, 6 joules, right? Obviously, a joule is a lot of energy and we are talking of just one bond. So these numbers are not correct. This is only to explain. तो हमारी 6 जूल एनर्जी लग गई, और इसको ब्रेक करने में कितनी लगेगी? क्योंकि सिंगल बॉन्ड की क्या एनर्जी है 3 जूल, तो इसको ब्रेक करने में तो केवल 3 जूल लगेगी, इसको ब्रेक करने में कितने लगेगी 3 और 2 5 जूल्स। सो ऑब्वियसली सबसे स्ट्रॉन्ग ये हुआ, इसको ब्रेक करना सबसे मुश्किल है, राइट। लेकिन यहां पे हम क्या बोल रहे हैं कि ब्रेकिंग द डबल बॉन्ड इज नॉट इजी, इसीलिए मैंने लैंग्वेज आपको जो बताई है, ब्रेकिंग द डबल बॉन्ड इज नॉट इजी बट ब्रेकिंग द सेकेंड ऑफ द डबल बॉन्ड इज इजी। यानी कि ये जो डबल बॉन्ड है, इसमें से ये जो दूसरा सपोर्टिंग बॉन्ड बना है, इसको ब्रेक करने की एनर्जी इस बॉन्ड को ब्रेक करने से कम होती है। Okay, you understand these two data points look contradictory, but they are not. So what is more reactive? Unsaturated is more reactive, क्योंकि breaking one bond out of the two bonds is easier compared to single bonds. But ये भी क्वेश्चन आ सकता है आपको कि इनमें से कौन सा स्ट्रॉन्गेस्ट बॉन्ड है, तो उसमें आप जिसमें जितने ज्यादा बॉन्ड्स हैं वो उतना ज्यादा स्ट्रॉन्ग है, तो ट्रिपल बॉन्ड इज द स्ट्रॉन्गेस्ट बॉन्ड, इसमें आंसर ये आएगा। समझ गए आप? तो ओके, वी हैव कम टू द एंड ऑफ द टाइम, सो द ओनली थिंग आई वांटेड टू डिस्कस वाज कि tomorrow we have another science class, so what is it that you want to revise tomorrow? Light K numericals you are comfortable with? We did very few numericals. Is that something you're comfortable with that?
Sir, are we
Yes,
finished
sir.
with this chapter?
You want to do this carbon chapter, you want to continue and do more questions on this?
Yes, sir.
Okay, so we will continue with this and we will do more questions from the current syllabus. Okay, after the pre-boards, if we could have more time, we can do some parts which are not even in the syllabus, so that you know it, and just in case of confusion, if something comes up, you will be able to answer that. Okay.
Okay, sir.
Okay,
Okay,
sir.
then just give me 1 second. I'll take a quick record of the attendance and then we can leave the class. Okay, thank you very much and bye-bye.
Thank you, sir.
Bye bye, sir.
Thank you, sir.
Thank you. Bye-bye.
Namaste.
Namaste. Bye-bye.